Hello everyone, this is the course on engineering graphics and we are discussing about projection of solids. This is the second lecture on projection of solids. In this lecture we are going to cover projection of solids with axis inclined directly or indirectly to one reference plane and parallel to another. The first case which we had discussed in the previous session, that was about projection of those solids whose axis is inclined to is at 90 degrees or perpendicular to one reference plane and inclined to the other, whereas in this case that angle of inclination is different. It is less than 90 degrees, so it is inclined to one reference plane and parallel to another. So let us take examples and understand this concept. A pentagonal prism, edge of base 40 mm and axis height 100 mm, has one of its corners in the HP and the axis is inclined at 30 degrees to HP. Draw the projections. Now what is given is the shape. First thing, pentagonal prism. Okay, the dimensions of base edge and axis height are given and it is having one of its corners in the HP. Now understand this thing, when there is something of the base or corner or edge or the complete base, anything is there in the HP or standing on the HP, then in that case you have to take that on HP. So we will break this problem into two steps. First step, before making the inclination of the axis with the reference plane, we will assume it to be perpendicular in the step 1, and then second step we will tilt it to the required inclination by the parameters given in the problem. Now this case, for getting the first step, you have to underline these words, that it is having something. It can be corner, edge or complete base in the HP or in the VP. If it is in the VP, then first step you have to take that on the VP. Now this corner is there in the HP, so step 1 we will take the solid with axis perpendicular to HP, and then later on we will tilt the axis so that its inclination is at the given angle. Now in this case the angle is 30 degrees to the HP. So let us solve this. So first step is the prism standing on its base on HP. Now whatever is there on the HP, then that side we will keep on the right side of the observer. Now here they have given that it has one of its corners in the HP, so we are going to keep one of the corner of the prism on the right side of the observer, and we will draw the front view and the top view. For this, in the top view we will get the pentagon and in the front view the rectangles. Okay, so that is the first step. And if we solve this, we already solved this first step in the previous session, in which the solution was consisting of only one step. What you will have this as the step 1 solution. Now you can see that top view, we are going to get the pentagon here with one of the corners resting on the right side of the observer. Observer is here, and on the right side of the observer we have taken the corner because it is resting on corner on the HP. Okay, and then we have drawn the front view. We see from this side, so we are going to see this face and this face. This is there, one of the face, and for this face this rectangle is there in the front view, and then the axis is also shown here. Now coming back to the question, it is not the complete solution. Now what is given is that we want the inclination of the axis at 30 degrees to the HP. What is required is axis should be inclined at 30 degrees to the HP. But what we have done, we have taken it to be perpendicular to HP. That is, inclination of the axis in the first step is 90 degrees with the HP. Now let us solve this on AutoCAD, and simultaneously let us understand the solution also. So this is what is the solution for the step 1, that the axis is taken perpendicular to HP, and we have taken one of the corners on the right side of the observer. So this is the corner on the right side of the observer is here, and the first step is done. Now we will solve the second step. Now second step, what is done is that the axis angle with respect to HP is 30 degrees. So we will tilt it, this figure, on this corner, so that inclination of the axis is 30 degrees. So for that purpose, we'll do little construction. First thing, we will copy this so this front view we will select and we'll copy it. Let us give this as the base point for copying it, because we are going to keep this point on XY line only, and move it aside. You see that snap settings are off, otherwise you will not be able to put it on the proper place, at proper place. So let us place it now. Okay, give some distance, keep some distance, and then exit the command. Now we have copied this. Now we will tilt this figure by keeping this point D prime on XY line only, so that the angle of inclination of this axis or this vertical face is 30 degrees with XY. So for that purpose, we'll draw a line at 30 degrees, the projection layer. So we will draw the line, and for that you need to switch off ortho and switch on angular or polar tracking. Now in this case you have to keep these 30, 60, 90 settings, so it is easier to draw the line at 30 degrees, and the point is here for the line, starting point. So switch on the snap mode, starting point is here, and now we will draw the line at 30 degrees. You can see the angle here 30 degrees, it is indicated, and the length of the line is not is not so important right now. We just want the inclination. So this is the line drawn at 30 degrees to XY. All right, now we will tilt this. So for that purpose, you have to select this rectangle again. You see that you are not selecting any other object except the rectangle. Okay, you are not selecting this line as well as this line, only you have to select this rectangle, that is this view. And now rotate, this rotate command you have to use, rotate. Okay, base point, give this as the base point. Okay, and now rotate it. You do not keep the ortho mode on, otherwise you won't be able to rotate. Okay, you see that ortho is off, and then you can rotate it and align this edge, vertical edge, with this inclined line of 30 degrees. Okay, and click there. So now it had been turned about this point corner, and angle of inclination of the vertical edge with XY line is 30. It means that the axis is inclined at 30 to this HP. Now this is the front view. in the second and final step for this. Now let us draw the top view from this front view. For that purpose, we will take projections. So projection layer, ortho should be on, snap should be on, and we will take the projectors from various points. Now we have drawn the projectors, vertical projector as well as horizontal projector from the first step top view. And now intersection points we should mark. For that, the command is point. Before putting the point, let us define the point type. For that, you have to type DDPT. DDPT means DD point type, definition of various point types available. Okay, by default it is this one. Okay, small point, so it is not so much visible. We will set it to this, and point size 3%, set size relative to screen, and okay. Now for inserting the points, type PO for the point, enter. And now you see that this is the projector from C, and this is the projector here, this one from the C prime. So this is the required point. All right, enter again. Then this is from B, and this is from B prime. So this one, enter again. Then from the D, and this is from D prime. Then E, and this is from E prime. I have not drawn from A, so I will draw that from A as well. So line, then again point A, and A prime here, A prime. So this is that point. Similarly, for the top base 1, and this is the 1. Then 2, and this is the 2 prime. Then 3, and this one is for 3 prime. Then 4 prime and 4, and 5, and 5 here. Done. For the axis points, this is the top point of axis, and here from the center you have it here, and on this side this is the axis point, well, the line, and this from this view. So this is that axis. Done. Now let us give the names. We have given the names to the corresponding points. Let us join them now. When you see from the top, for drawing the top view, what you are going to see, you are going to see this top base completely, and these edges. Okay, those edges which are nearer to the observer, they are visible, and we have to join them with object line. So layer is now object layer. Change the layer to object layer. Okay, and then line, and start connecting this top base edges because the top base is completely visible. Ortho can be off now because inclined lines also we are drawing. All right, and then we can see A1 and B2. A1 B2, then the outline has to be dark. What is there on the outline? AB, BC, C3, similarly AE, E5. Done. Now remaining all the edges should be connected with dotted lines because they are not visible from the top. So when you see from the top, they are not visible. Which are the edges which are not visible? You cannot see DE and CD for the bottom, and the longitudinal edges D4 is not visible, E5 is not visible. So let us join these by hidden lines. So hidden layer, line, this is one of the hidden edges, again line D4, so this is connected by hidden line. And then the center line. For that the layer is center layer. Now this is this point to this point actually. Okay, I have not drawn the hidden line completely. 4 point is here. Now center line. Center line is from this center to this center here, but it is getting overlapped by hidden line. So that portion which is not getting overlapped, let us connect that much. So this is how we have drawn this much only center line, and that is the complete solution for this sum. Now we have solved this. This is the second position, that we are tilting it on one of its corner, and we have drawn the views in the second position as well. So this is that solution here. Now let us solve this now. A hexagonal pyramid, edge of base 30 mm and axis 100 mm, is lying on one of its triangular faces on ground. Draw the projections. Just see, the solid is hexagonal pyramid and it's lying on triangular face on the ground. As I said, something is on the ground. In that case, you have to take the first step as the axis perpendicular to HP. HP means ground only, so axis perpendicular to HP, that is the first step. And second step, we will tilt it so that the triangular face will lie on the HP, and that is the second and the final stage solution for this problem. So try to imagine the positions. So this is the first step. It is simply kept, the pyramid is kept on its base on HP so that the axis is perpendicular to HP. This is the first position, and correspondingly the solution for the first position is this one. We already solved this in the session 1, lecture 1. So this is how it is kept. It's a hexagonal pyramid, so hexagonal pyramid is just kept on HP with the two base edges perpendicular to XY here, and in the front view you're going to see these two triangles. Okay, now this is the first step. Second step, we are going to tilt it on this edge, so the triangular face will lie on HP. The triangular face here will lie on HP. So let us solve this on AutoCAD. So this is the first step. We will continue with this and draw this second step. Now second step, we are going to keep this edge, this is DE, we'll keep this on HP only and tilt this so that DO, this slant edge, will rest on XY or HP. So this is the second step. Let us solve this for the front view first, and then we will take the projections from the top view, projections from the front view, and complete the second step, top view. So for that, let us draw this. Just copy this. This is the front view. Copy with this as the reference point and place it here. So one instance of copying it. Now we simply want to rotate this so that this becomes flat, or this will lie on XY line. So this is our XY line. Just little bit stretching is required. Further ortho mode is required so that it will draw the straight line. This is drawn, and now we will rotate this. So simply select this again and rotate. This is that point about which we'll rotate. Ortho should be off now, snap should be off, and rotate it gradually and bring it in line with XY line and leave it. So this is the front view of step 2. We can bring it nearer because there is wide gap between these two steps. We can reduce that. Again select this, move. This is the reference point, snap is required, and move it orthogonally so it will lie on. It is taking the snap point. Okay, snap should be off. We'll keep this, move it and keep it here. So this is how it has been drawn now. We'll take the projections, line, projection layer, and let us draw the projectors. Snap should be on. Okay, we have taken the projections. Now we have to name the points wherever they are intersecting. Now these names we have given now. Let us join these points. You are seeing from this direction. You are seeing from this direction. So the edges which are nearer to you, those edges should be connected with object line. You can see that the base is completely visible. So let us connect that with object lines. So object layer, line. Ortho is not required. Now just connect this. So this is the base, and slant edges are also visible, which are particularly on the outside. Now this is CO and FO, those are visible. Okay. What about BO and AO? Yes, they are also visible. AO and BO, they are nearer to the observer. And what about DO and EO? No, they are not visible. They are lying on the ground or HP. So they should be connected with hidden lines. Okay, done. And now center line or axis line. For that center layer, line, so this is drawn. Dimensions are also given, and this is the solution. Okay, so this is the solution. Now we'll solve more problems. See this, a hexagonal prism, edge of base 30 mm and axis height 75 mm, has its base edge perpendicular to HP and in the VP. Understand that the base edge is in the VP. It is important. So first step, you have to take the axis perpendicular to VP. Draw the projection if rectangular side face containing that edge. Which edge? That edge of the base which is perpendicular to HP, the rectangular face containing that base edge is inclined at 30 degrees to the VP. So this we need for the second step. First step, we will take the solid lying on VP with the axis perpendicular to VP. So we will see the polygon in the front view. Now this is a hexagonal prism, so we will see the hexagon in the front view. In the top view, we will see the rectangles. This is the model. Okay, so front view, we will see it here from this side. We will see this polygon, and one of the rectangular faces, say this is that rectangular face 1 and 2, they are both perpendicular to XY line here, so that is satisfying the condition. In the second step, we will tilt it, and this rectangular face will lie on, or rather inclined at 30 degrees to the VP. Okay, that is inclined at 30 degrees to the VP. So that is we'll do in the second step. Second step, the inclination of this with VP is 30. Let's see the solution here. First step, front view, we are going to see the hexagon, alright, and top view, the two rectangles are visible. Let us get the solution on AutoCAD. You can see that first step solution is already done now. We will tilt this face at 30 degrees to VP in the second step. For that, let us copy this, the top view. Copy, paste, and then tilt it. So we have tilted it, and I will take the projection from this view and complete this front view for the second step. Okay, I already done that and inserted it now. We are following the same procedure. We'll take the projections from these corners or from the front view, and intersection points we will mark, and then later on join them using the logic. See that the joining logic is this, you are seeing from this side. So the edges which are nearer to you will be connected by object lines. So when you see from this side, what is being seen is this base, top base completely visible. So that is all points connected with object line. And 1A, 2B, this is visible. So 1A, 2B is visible, and then 3C and F6, because they are on the border, so these are visible, so object lines. The remaining all should be connected with hidden lines. So that is what is being done here, hidden lines, and then the axis line is shown with the center line. So this is the solution. Let us solve few more sums. Pentagonal pyramid, edge of base 35 mm, axis height 70 mm, has one of its base edge perpendicular to HP. The triangular face containing this base edge lie in the VP. Read it carefully. What is given is this pentagonal pyramid. Okay. Edge of base 35, axis height 70 mm, has one of its base edge perpendicular to HP. Understand? One of the base edge is perpendicular to HP. Okay. Triangular face containing this base edge lie in the VP. This is important. What is it? Lying in the VP means anything lie in the VP means you have to take the axis perpendicular to VP in the step 1 or first step, and later on make the inclination, requisite inclination for the axis in the second step. So first step we will keep it on VP, the pyramid is kept on VP, and in the second step the triangular face containing one of the edge is lying in the VP. So this will lie in the VP in the second step, and we will complete the solution. We will complete the front view for the second step. Just see this object. First step we are going to keep it on VP. So we are keeping it on VP. We are observing it from this side. So front view you will see the pentagon with one of the edge perpendicular to XY. And second step we are going to tilt it so that the triangular face will lie on VP. Okay, we will tilt it so that this triangular face which is there will lie on VP. So first step, and we'll do this in AutoCAD. So the first step is ready. Draw the XY line here. Okay. Now we'll draw the top view. We will tilt this, or we will lie it on XY line in this step, and then take the projections from this view, and we'll get the point of intersection, and then later on join them. Snap is off. Redo it again. See, we have followed the normal process. We will first copy it here and then rotate it so that this edge will lie on XY line, and then take the projections, and then take the projections horizontally from this step. All right, and then we'll get the points accordingly. We'll join the points. So we see and join the points. Nearer edges are connected with object lines. When you see from this side, you will see the complete base. So complete base is connected with object lines. Then A0, so A0 object line, then BO and EO, so BO and EO, and remaining edges will be shown with hidden lines, that is these edges, hidden line, and the axis line is shown. So this is the solution. Now we'll see one more and then we will finish this session. Now this is for this right circular cone, diameter of base given as 40 mm, axis height 75, is resting on a point of its base circle on the HP with apex 70 mm above the HP. Draw the projection. So first step, it's resting on HP. What is being resting on HP? One of the point on the circumference. So resting on a point of its base circle on the HP means something is on the HP means first step, take the axis perpendicular to HP. So in the top view we'll see the circle, in the front view we'll see the triangle. So this is how we'll see in the object. We'll see here. So front view triangle, top view cone, so circle. Second step, we will tilt it so that this apex is 70 mm above XY, and then reproduce the corresponding view by taking projections. So first step, axis is taken perpendicular to HP. So top view will get the circle, front view will get this triangle. Now you see that this circle has been divided into multiple parts, minimum 8 parts we should divide. I have divided it into 12 parts to get the smooth curve in the second step. You can see these are the generators, so they are not drawn with object line because they are imaginary generators drawn on the circular surface of the cone. And the second step, we are going to tilt this, keeping this on XY. Okay, sorry, it is not visible. I am not using laser pointer. Now laser pointer. We will keep this point on XY and tilt this so that the apex is 70 mm as shown here. It is 70 mm above the XY line. You can see that it is 70 mm. We'll draw one locus, and from this point we'll take this distance and cut on that, and then reconstruct this figure here. Take the projections down. Take the projections, horizontal projections. Take these projections down and take horizontal projections from the first step, and point of intersection, name them properly and join the points you are seeing from the top. So whatever is visible, that is shown with object line, and that hidden portion is shown with a dotted line, and then the axis is also shown. So let us stop here. In the next session, third session in this series, we will see the problems wherein the axis of the solid is inclined to both the reference plane. So we have to solve that into 3 steps by converting it into 3 steps. So let us see that in the next session.